All right, 2.4, solving two-step equations. Now, two-step equations require that we use two principles of equality. So take, excuse me, take 30 seconds and see if you can solve this equation or find the value of x that would make this a true statement. Okay, 30 seconds, go. So there's our principles of equality. Remember, whatever you do to one side of the equal sign, you got to do to the other side as well, whether it's addition, subtraction, multiplication, or division. All right, so on a problem like this one, and again, if you guys need more time, just keep working on it, okay? But we should be able to use just two principles of equality to solve it. Now, from that last section, 2.3, we know that we should only be looking to make zeros and ones, right? Because in the end, what I really would like to see is 1x equals something, okay? So we know we need to create a 1 there. But before we make ones, we usually make zeros. To put this a different way, okay? What we want to do to start out with is to make the x's on their own side of the equal sign. Or, to put it even different, it's to isolate the x's. Okay, that's one way they'll say it sometimes in other videos. So I don't want 2x plus 4. I want to make this right now just 2x. That isolates the x's. Well, what that means is I need to change that plus 4 into a 0, right? I'm manipulating that plus 4 into 0. Well, how do I make a positive 4 a 0? Bam, just subtract it from itself. Now again, what I do to one side of the equal sign, I got to do to the other side of the equal sign. So I'm using this upside down t method. Not that you have to, but 10 minus 4 is 6, right? So 2 times something is 6. So that was 0 right there. That created that 0 for us. It's a phantom 0. I don't have to look at it. I don't have to see it. Not out of hatred, but just because it's math, okay? So I've got 2 times something equals 6, but I don't want 2 times x. I want 1x. How do I make a 1? From a 2, just divide it by itself. Anything divided by itself is 1. Just remember, if you do it to one side, you got to do the other side, okay? So 6 divided by 2 is 3. Now this should be my answer, right? Because I got 1x equals something. And 2 divided by 2 is where that 1 came from, right? That's that 1 right there. But just like we went over in that last section is, once you get an answer like this, please take the 10 to 15 seconds. If you're slow at typing, maybe it takes a minute, but I know some of you guys are really good at texting. You guys can really make your phones, we can see the smoke coming off your phones, but just take a minute and just type this into a calculator just to check, okay? So what that would mean is that, right, it was 2x, but now we say x is 3, so it's 2 times 3 plus 4. Just make sure that this does equals 10. So 2 times 3 is 6, plus 4 is 10. Does 10 equal 10? Yeah, that's true. So again, now that I know this is true, I can box this in with a lot more confidence. And I can feel pretty good about it on a test, okay? And again, I'll emphasize this also, is it's not required that you show this work right here. But I highly recommend, this is the sign of a very good problem solver, is where you guys actually do it and do show the work. So I recommend that you do, but again, it's not required that you do it. All right, so here's another problem. We should be able to do this in 2 steps, right? Or with 2 principles of equality. So remember, in the end, I want this to be 1x. But right now, I can't do that in 1 step. So I got negative 3x plus 1. I'd like that just to be negative 3x. Okay, so I don't really want to see that plus 1 with it because I'm trying to isolate the x's. So how do I make that a plus 1 go away? Again, that's to make it a 0. How do I make it a 0? Bam, you subtract 1. So whatever you do to one side, you got to do to the other side though. So positive 1 minus 1, that makes that a 0. Negative 14 minus 1, negative 15. So I don't need to show the 0 there. I'm showing the work right here, but I'm not showing plus 0 right there, right? Because I want that to be a phantom 0. So I'll just get rid of that garbage. So this is what I wanted to start with. So I've turned this into a one-step equation. But I want that negative 3x to be a 1 right there. How do I change any value to a 1? Just divide it by itself. So if I do it to one side though, divide by negative 3. I got to divide by negative 3 on the other side of the equal sign. And negative 15 divided by negative 3. There's two negatives there, which makes that positive. 15 divided by 3 is 5. So 5 would equal x. And again, you do not have to show the 1 there if you don't want to. But you're welcome to if you'd like. But again, we should just check this real quick. So does negative 14, does that equal negative 3 times 5 plus 1? Again, I would just type this into a calculator. Negative 3 times 5 is negative 15 plus 1. Yeah, we can do it by hand. So negative 14. There's no operations on the left, so that's just negative 14. That's true. So again, I can circle this. I can box it in. I can type it into the homework with a lot of confidence on that, okay? Now, this section is two-step equations. This one really is not going to require 2 steps. But it is a unique problem, which I would assume we'd see on the homework. So I got negative g equals 18, right? But what's the coefficient of g? So that's going back to, what was that, 2.1? 2.2. What's the coefficient of g? That's a negative 1, you guys. Well, we don't want the coefficient in the final answer to be negative 1. We want it to be positive 1. So how do I change a negative 1 into a 1? Again, just divide it by itself, negative 1. But if you do it to one side of the equal sign, you have to do it to the other side of the equal sign. So 18 divided by negative 1 is negative 18. Now, taking this one in the calculator is, it may be a little challenging. I think what you have to do is you have to type the negative, but negative g, right? And g is negative 18, so I would use parentheses and just push equals. But does this equal 18? Question mark. And yeah, that's 2 negatives there to make it positive. 18 does equal 18, that's true. So there's my answer right here. G equals negative 18. So I like to show this one because it's it's one of those ones that it just gets a few students. It's like, well, I'm not used to seeing negative g. Again, if you show it as negative 1, hopefully this helps to solve this type of problem, all right? Because some students, they just put 18 and say, well, 18 is 18. But remember, it's a negative, so we got to take the opposite of that value. The answer would be negative 18. So here's another problem with some fraction stuff in it. It looks like we'll see another one, but let's go and make this bigger. All right, so I got x divided by 4 minus 7 equals negative 1. I don't want that that minus 7 business, right? Like right now, if I can just get to x over 4, or x divided by 4 equals something, then I will have set this up as a one-step equation. So how do I make that minus 7 go away? Again, it's to make it a 0 by adding 7 to both sides of the equal sign, okay? And this maintains equality. And negative 7 plus 7, that is 0. Negative 1 plus 7, that's positive 6. So something divided by 4 equals 6. Now for the principles of equality, I don't want that divided by 4. I just want this to be x, right? Or 1x. So how do I make that divided by 4 a 1? Just multiply it by 4 in the numerator. But again, if you do it to one side, you got to do the other side of the equal sign. Again, that makes that a 1, 1x. And 6 times 4 is 24. So let's go back and check, right? 24 divided by 4 minus 7. Does this equal, what's it equal? Negative 1? Well, let's find out. 24 divided by 4 is 6, which we saw right here. And we should see this kind of working backwards from the way that we did it, right? 6 minus 7, does that equal negative 1? Sure does. Negative 1 does equal negative 1. So that's true, and I know I can box this answer in with great confidence. Next up, 24 equals x divided by 5 plus 9. All right, just, you know what? You guys take 10 seconds, see if you can solve this one, all right? I'm sorry, 30 seconds. 30 seconds, see if you can solve it. All right, let's go ahead and get started on this. So the first thing we want to do on this one, let's get rid of that plus 9, all right? We're going to zero it out by subtracting 9 from both sides of the equal sign. Again, this isolates the x over 5. It's going to become a 0 there. 24 minus 9 is 15. So 15 should equal x over 5 or something divided by 5. But I don't want x over 5, I just want x or 1x. So if I multiply that by 5, that makes that a 1. But again, if I do it to one side of the equal sign, I should do it to the other side. Let's show the multiplication for this. 15 times 5. So there's a 25, carry the 2. 5 times 1 is 5 plus 2 is 7. So the x ends up being 75. And again, let's just check our work. Does 24 equal, that's a question mark, x, so 75 over 5 plus 9. Well, 75 divided by 5, again, we see this value come back, 15. 15 plus 9 is 24. So that is a true statement. Again, you could just type it into a calculator. That would have been fine. So this value of x would make that original equation a true statement.